Hello, everybody. Thank you for joining us. We are here in the webinar to show you how you can visualize and forecast information with Snowflake, Preset, and MindsDB. We believe that these three tools are the most fantastic combination for you to forecast information that you have in your database and for you to actually use the power of machine learning right where your data lives and also to visualize it in a BA tool like Preset. So we're very excited about this. We have here myself, Jorge Torres. I'm the CEO at MindsDB. Miles Atkins, he's a sales engineer at Snowflake. And Srini Katdamati, he is a senior data scientist at Preset. And the way that we're going to go through this, we're going to start with Miles. He's going to walk us through the approach that Snowflake has at data science and incorporating tools like MindsDB and Preset. And then myself, I'm going to walk you through how MindsDB plays into this role of adding machine learning capabilities to the landscape of data. And then we have Srini. He's going to walk us through a demo on how to actually see the information that MindsDB generates for forecasting all within the Preset BA tool. So I'm going to hand it over to Miles. Miles, the floor is yours.
Great. Thank you for that, Jorge. And yeah, just before we get started here, so my name is Miles Atkins. I'm a partner sales engineer here at Snowflake, and I lead the technical go-to-market for Snowflake's machine learning and data science ecosystem of partners, with MindsDB being one of those. Just a little bit more background about myself. I've spent the entirety of my career in data science and sales engineering positions, and I have some prior experience in financial markets and technology industries as well. So happy to be here. Thank you for having me. And to kick things off here, and kind of why we're here today, it's no secret that there's this transformational shift happening within the modern business world, from the what and why to what will happen and how can we kind of make it happen, right? Going from that traditional, kind of historical to can I start to predict, outcomes for my business, and ideally those are going to drive value for your business. And at Snowflake, we're really kind of just seeing this happen right before our eyes, given our spot as a cloud data platform and the plethora of questions that come inbound on how to use Snowflake for data science, which we will dig into as we kind of go throughout the webinar here. And when it comes to the data science maturity of our customers, which Snowflake has over about 4,000 now, we see a great range of customers trying to get their first models into production. We see them getting their operations set up on cloud scalable technologies to where customers can now have hundreds of models in production as well with robust pipelines. And so we really kind of see still the nascent side, but also the mature side. And so, with that, there's a spectrum where everyone's going to fall. Now, for those of you that are new to Snowflake, Snowflake started as a cloud data warehouse and grew into an end-to-end cloud data platform. We now support 6 distinct workloads with the ability to work on all 3 types of data: structured, semi-structured, and unstructured data. And what this enables is for you to do your data engineering, your data warehouse workloads, data science, data applications, data sharing, and data lake, all with one copy of the data located in your cloud provider of choice. And so to give you a quick overview of the Snowflake architecture, Snowflake is comprised of 3 isolated layers that are all decoupled from each other. At its core, as I just mentioned here, Snowflake leverages cheap blob storage, which is unlimitedly available from Snowflake's 3 main infrastructure cloud providers, so Google Cloud, AWS, or Azure. For the next layer, we have compute. Compute houses are available on demand, where you only pay for what you consume, with the ability to scale up or increase the size of a warehouse. So you can think of, I had a small data set, and 2 years later, in business, my data set is now much larger. how do I get the compute resources to now, increase with that scale in data? We can then scale out as needed for specific workloads by turning that into a multi-cluster node. And so you can think of, I had a team of 2 data scientists, and now we're up to 8. How do I allow those additional, new hires as they come on board to have that kind of same experience my current team has without having to buy all this new infrastructure and that sort of thing? And then the last dimension here is allowing you to scale across as well. So you can think of, we were doing some data science in our IT department, and now our sales department wants to start doing forecasting for sales. How do I spin up and give those people infrastructure and access to the data? And so that's kind of scaling across, you can think, your business, and Snowflake allows you to do that. And then lastly here is Snowflake's cloud services layer, which enables Snowflake to be delivered as a service and encompasses all unique features to the warehouse space. For example, data sharing, both private and public data exchanges, security and governance with role-based access control and row-level security, and then a bunch of metadata that enables things like extreme query pruning to drive query performance. And so with that, today we're really going to narrow in and focus on that data science workload. And to give you a taste of how we at Snowflake think about data science, it's really defined by this pretty standard machine learning lifecycle photo that I have here. Obviously, your collection of data, doing your visualization and understanding, future engineering. We believe and we think you should really be able to do all of this natively inside our cloud data platform. And of course, you're going to get all the benefits of the scale, governance, security, all those things mentioned before. Now, Snowflake doesn't do machine learning training. And so this is where we rely on our partners, such as MindsDB, to come in and go to market together to help you build out that end-to-end solution, which at the end of the day is going to drive value. And then lastly, on the evaluation side as well, Snowflake doesn't have any sort of, let's call it, prediction engines that allow you to, score models rapidly on demand. And this is where we rely on MindsDB as well to help us and integrate with them closely to, again, enable that experience. And so with that, I'm going to pass it back over to Jorge here, who will talk you through democratizing machine learning.
Thank you, Miles. So we play very well with Snowflake because of the philosophy that MindsDB has, which is the life cycle of machine learning. The data preparation side is very well done by Snowflake. And let me walk you through that. If you think of the MLOps lifecycle, you have the data preparation, you have the modeling, and you have the deployment. And we believe that if your data is already in Snowflake, you've accomplished that first part. And let me tell you the intuitions behind this. The way that most people learn machine learning today is similar to how you do research, or like how people do a PhD. And that is not necessarily the best way to apply machine learning. You cannot start with a pandas data frame and start massaging your data and assume that that's the way that it's going to go into production. Usually the people that start with pandas, they start with an ideal data set, but how that data set happened to be, it's unknown before you make it into production. The intuition here is if you treat it like this, then you end up doing an application for machine learning, or you end up treating machine learning as part of another application stack. And this actually is very complex because you're going to have to ETL from the database or your lake or your data warehouse to the data model. And you're going to have to create that through either Python scripts that replicate whatever you're doing in pandas. Then you're going to have to feed this information into the model. And then this model has to be served either in a web service or some sort of deployment mechanism that allows you to consume it. And you're going to have to pipe data from where the data exists, let's say in your data warehouse, to the model, and then you're going to get the predictions out, and you're going to pipe that back into the data warehouse. So treating this as an application certainly has a lot of roadblocks. The idea here is that perhaps you can treat the model first, or the machine learning problem that you have, from where the data lives. If you want to apply machine learning, perhaps you should start with, where does my data live? And in this case, we believe that Snowflake does provide all of the things that you need to do in order to actually do your data preparation and feature engineering. The cool thing is that SQL has been around for quite a while, and SQL in Snowflake allows you to do virtually anything you want to do to your data. So you shouldn't be doing things outside, when it comes to data preparation, outside of Snowflake. And everything you run in SQL, at the end, you get a table. Those columns are features. So you can think of the data preparation lifecycle, or the step of the data preparation within the machine learning lifecycle, to be complete when you're doing it in Snowflake. You've already figured out how to do data acquisition. Snowflake provides for all the capabilities that you need for data preparation and labeling. And then anything after a query is what you can call feature engineering. Yes, there is a step for encoding that data so you can fit it into a machine learning model, but that is something that can be automated, and MindsDB helps with that. But think of SQL as the most powerful data preparation tool for machine learning, or that's the way that we see it for applied machine learning. Now, the intuition that we had is, what can we do to do the rest, the modeling and the deployment, within a similar environment to the one that you're used to? In this case, using the SQL syntax, or a very similar SQL syntax to the one that you use for data preparation. Can we create models with SQL? That's the question that we were asking ourselves, and that is the intuition that we created, or the basis upon which we created MindsDB. To walk you through that intuition, we created a concept called AI tables. And let me walk you through an example. Imagine that you have a table that is called income table, and you want to visualize this information. So if you select income and debt, and you were to see those dots on the right-hand side, then if you run a query, the database or the data warehouse is kind of designed to match a specific data point that already exists in your database. And in this case, let's say you want to find the income and debt for when your income is 80,000. If you have an exact match, you're going to get results. However, if you query for something that is even very close to one of the data points that you have, databases are not designed to give you an approximation. And that is what you can solve with machine learning. With machine learning, you can actually build a model that can fit this data. Now, the intuition that we had is, well, if you think about a machine learning model, at the end, they're just another representation of the data, or continuous representation of your data. And it would be really cool if you could build that model very similar to how you create other representations of data in your database, like how you create a view. And the syntax that we came up with is, well, you can create a predictor, you give it the name of the predictor, and then from what information you want to train from. In this case, it can be either a query or it can be a table, and then what column you want to predict. MindsDB leverages on the best understanding of AutoML, and it can create that model for you using the framework that we have for AutoML called Lightwood, which is based on PyTorch. But also, if you actually know, and you want to tweak the different parameters for creating this model, MindsDB gives you a syntax to specify the model type, how you want to encode the data, and how you actually want to get to that prediction. So you can let the AutoML drive for you, or you can specify as much as you want of this model building, but all within a syntax that is very similar to how you create a view. Now, the cool thing about this is that once you create this predictor, you can query this predictor the same way that you create or query a table or a view. So in this case, we're going to query not for a data point that you have on the data that you trained from, but you can get an approximation for when the income is 90,120. So you query, select income debt, the predicted debt from the debt model, and then you specify whatever you have on the where. Whatever you have on the where is going to be the input for the model, and then you're going to get a forecast in return. So by doing this, making this abstraction of creating models in a declarative way through SQL, then the modeling part is already covered, and it's covered in a way that is very similar to what you're used to doing in Snowflake. Now, you've covered the data preparation and the modeling, and you're going to think, what about the deployment? The interesting thing here is that deployment is a very natural concept in Snowflake, for the very same reason in MindsDB. When you do create view in Snowflake, that view is already deployed. And the same thing happens when you do create predictor. As soon as you do the create predictor statement, that is already created within MindsDB, and it can be consumed just as you consume any other view. Okay, so let's jump into what happens after we start dealing with these problems in machine learning. So we deal with very difficult problems in machine learning that are very common in the database. And these are problems that have high cardinality, high frequency. And let me walk you into an intuition of this. Imagine that you want to forecast how routes in the Chicago Transit Authority behave over time. Let's say you are the Chicago Transit Authority data analyst, and you're tasked with understanding how are you going to assign resources, or in this case, buses, to different routes. But these routes tend to be sometimes very difficult to forecast over time. So the question that you may want to answer is, well, you need to understand what is the number of buses that you're going to put in a given route. And for that, you're going to want to analyze what is, given the information that you have on the past, the number of routes that you're going to have next week, or the number of routes that you're going to have every day during the next week. So think about this problem. Imagine that you have the routes and the timestamp associated to every single route. So every day you have the number of rides that you have in a given route. This is what we understand as a time series problem. A time series problem tends to be a very hard problem to solve, even if you know what you're doing in machine learning. Now, the problem here is that in a database, they tend to be even more complicated. In a database, you may also have other columns associated to that specific timestamp. In this case, you may want to have the type of the day that you specify, or the price of the routes that given day. So in the world of databases, it's very common to have time series problems that are also multivariate. And not only that, you don't have just one single route in this database, you have many routes in this table. So this falls within the category of high cardinality. What this means is that you have within one single table, not just one single time series problem that is multivariate, but you have a problem that has a lot of time series, individual time series kind of like bound to a route ID. And therefore, if you were to do it in the traditional way, you will have to train a different model for each of the routes that you have. MindsDB solves these problems for you with one very simple syntax. And to get you to that understanding of how MindsDB does it, let me actually walk you through the real demo. Okay, let's start from the basis that you have MindsDB running either on your cloud, your computer, or that you're actually running through MindsDB Cloud. Again, MindsDB Cloud is the same thing that you find MindsDB open source. It's just that we manage it for you, so you don't have to deal with that. And it's actually, very convenient. Once you log into your MindsDB Cloud graphical user interface, you can actually create a database integration. MindsDB supports the same parameters that you pass that you will usually see in any client that supports Snowflake. So you specify the database. In this case, we're going to connect to the Chicago Transit Authority database. You specify the host, the port, your account, your warehouse, local query is usually the one that you go for, your schema, and then you pass your actual Snowflake credentials. Once you do this, then you can start playing with MindsDB, connecting to it from any MySQL client, because MindsDB speaks to MySQL protocol, and happens to be the coincidence that most clients that support MySQL also speak to Snowflake, and therefore you're probably going to be using the same tools that you already use. And in the following example, we're going to use dbeaver as one of the most popular ones. And in 3 simple steps, I'm going to guide you through the process of visualizing the data you have in Snowflake, as well as to create a model for the task that we have in hand, which is forecasting the number of rides in a particular route or particular routes within the Chicago Transit Authority. So let's jump into dbeaver and let's start solving this problem. Okay, here in dbeaver, you can connect to MindsDB and you pass the same type of credentials that you usually pass to any MySQL client, where you connect to, in this case, my cloud account and logging in with my MindsDB cloud credentials. And once you do that, you can start running queries into MindsDB, normal queries, SQL queries, and some extension of those queries to actually do machine learning. So I'm going to break this into 3 simple steps. The first one is your training data. And in that one, we're going to start by visualizing the databases that we have in Snowflake. So let's look at this. MindsDB ships with 3 simple databases. The first one is the information schema, where you can get information about MindsDB server as a whole. You have the MindsDB database or the MindsDB schema, where you can see metadata about the predictors that you train or the models that you train, as well as to access each of those predictors as tables. And then you have data sources in case you want to upload files. You're not necessarily connecting directly to a database, or you want to mix information that you have from a database with information that you have in some files. And in this particular case, the integration that we created from the graphical interface, the Snowflake one. And let's see the data that we have there for this problem. So I'm going to switch to that database. And then I'm going to explore the public CTA bus rights data that we have. And let's see how that is going to be useful for our problem. This table has a few columns. It has route, date type, and rights. And if you can see, this particular table has the specific number of rights per route throughout time. And then also another column that tells you if that day is either a weekend or a weekday. We're going to use this table to actually train a model to forecast that number of rights so that we can actually make a proper forecast of how busy a particular ride is going to be, and therefore how many buses I should allocate to that route. So the second step is to actually train a predictor. MindsDB makes this very simple. Even though your information can be a very complex time series problem, in this case multivariate with many different partitions, as we described before, MindsDB simplifies this in a syntax that makes it as simple as when you create a view or a table. So let's explore this a little bit more. Let's switch back to MindsDB and see what's going on there. We're going to see the tables that exist in MindsDB. And MindsDB comes with or chips with 2 tables, the commands and the predictors. Predictors is the one where you can see the status of the predictors or models that you're training. And then every time you train a new model or predictor, you're going to see them as a table here. Let me show you how the predictors look like. For this particular example and this particular demo, I have already a pre-trained predictor for the number of rights given the table that we have of CTA bus rights. And the reason why I'm doing this is because usually time series problems and time series models take a little bit to train. And for us not to wait a few hours to get this all done with, we're going to train a new one, but we're going to use the one that I have already trained for the case of this example. Now, training a model in MindsDB is as simple as creating a view or another table from a table. And the syntax is very simple. You specify the name of the predictor. In this particular case, we're going to tell it that it's going to be called rights predictor underscore tests. And then you specify from what data you want to learn from. In this particular case, we want to learn from that table that I showed you before, which is the CTA bus rights latest. And since that table contains information from all the way back to 2020 or January 2000, you actually probably want to train a model just from like the last 20 months. And that may be way enough data for you to actually solve this problem. The next thing that you want to specify is of the columns that you have in that table that you're training from, what is the column that you actually want to forecast? So we're going to forecast the column rights. And the next thing that you're telling MindsDB is that this is a time series problem. Essentially, that the information that you need to forecast is not contained in one single row, but in multiple rows, and that you can organize those rows by the column date. And not only that, but you're actually having in this particular table many different time series. And you're going to discriminate each of those time series by a partition. And the partition is defined by the values on the column routes. The next thing that you want to do is you actually want to take into account just the last 10 rows for every given prediction, and that is what you define as the window. And for the problem that we have at hand, we want to forecast for the next week, so the next 7 days, and our horizon is 7. So let's run this query. What MindsDB does behind the scenes here is that it tries a few different models and a few different building blocks to build your predictor. And this is due to the powerful automated capabilities that MindsDB has. But if you're dangerous enough and you know what you do in machine learning, or you actually want to tweak them, MindsDB allows you to change the behavior of your model as well as all the hyperparameters. But for now, and for this simple example, we're going to go for the simple syntax where you let the AutoML drive it for you. And in the back, MindsDB is training the model. Let's see that that is actually happening. What you can see here is that we have the model that we had already pre-trained, as well as the new model that is training right now, writes forecaster_test. What we want to do now is use that actual model. And the third step is very simple too. You actually have data in your database that now you can join into the model, or you can query this model with a where statement. Given that this is a time series problem, you actually want to join it with the table that has the historical data. So in this particular case, you're going to join the table CTA boss writes latest with the predictor that we just trained, which is the writes forecaster demo. And what you want to do here is you actually want to also forecast for when the date is greater than latest. This greater than latest is a syntax that MindsDB provides for you, so you don't have to go and actually fetch the latest information. MindsDB knows that it goes to the latest of your data set and pulls the window of information as you define to be the window when you train the model, and uses that to actually make the forecast. And in this particular case, we're going to train for, or we're actually going to forecast for route 171. Again, running this should be very simple. And this is very powerful. You know, in one single statement, you've managed to use a trained model that also combines the information that you have in your database to forecast into the future what would be the amount of writes or the projected number of writes that you will have for the next 7 days for this particular route. And you can do this for other routes. Let's pick route 19. The beauty of this is that MindsDB abstracts all the complexity of model building, model deployment, all through SQL, which allows you to think of the data that you want to use, train models using the same syntax or a very similar syntax that you're actually used to when you create a view. And lastly, you can join these predictors with the information that you have without thinking too much about data preparation, especially when it's time series. This can be a daunting experience. So I'm going to hand it over to Srini. He's going to walk you through how to take this demo and take this information and actually visualize all of this in Preset, which is a wonderful BA tool.
So if we fire up our Superset workspace, you can see that we have a direct connection to Snowflake, which this contains data from the Chicago Transit Authority, as well as predictions from MindsDB. Let's take a closer look at the data sets in the Snowflake database. Let's hop over to SQL Editor, which is one of the best ways for exploring data sets in Superset. Pop open the schema that we need, and the two data sets we're especially interested in are stops by route and forecast. So let's look at stops by route. If we look at stops by route, we can see that it has all of the latitude and longitude points, as well as each of the route IDs and the associated volatility. Let's pop open the forecast data set now. Great. Forecast actually contains the route ID, as well as the actual value of riders, as well as the forecasted rides, and then the confidence interval and the lower and upper predictions as well for this given timestamp. So this is pretty great. MindsDB has done a great job fitting into the data that was in Snowflake. So next, this is a BI tool. So let's actually start visualizing some of the data. We'll head over to the Datasets tab, and then from here we can filter our data down to Snowflake, and we're interested in stops by route and forecasts. Let's first build a map of stops by route that actually helps us visualize and understand the routes and their associated volatilities. So we'll change the map type to DECGL scatterplot, and then we'll actually pop in the latitude and longitude values. So latitude, we can also grab it from here if you want and drag it in. So let's do that, and then we'll open this up a little bit more. Let's also add in volatility percent as a dimension. Let's see what this looks like. Excellent. So we can kind of easily see each of the route IDs as well as the volatility associated with each of them. So this is great. We're able to do this with just a few clicks. While this map kind of shows us a lot, it's always better to create a dashboard and create something that we can actually share with the team and the rest of our organization. So we will actually go ahead and save this. Let's give this a name real quick. Map of routes and volatilities, and we'll save this as a new in a new dashboard. So let's call it routes, CTA routes and predictions. Here we go. Pretty simple. We'll save and head to the dashboard. Awesome. Now that we see it here on the dashboard, this legend here is actually not super useful. So let's actually resize this real quick, save it, and let's go back and edit this chart real quick so that we can remove the legend. So let's just find the legend. Legend position, none. Great. Legend is gone. You can save it now. Let's overwrite, and we won't look at the dashboard since we were just there. So the next thing, let's look at the forecasted data. That's kind of what we're here for, is to predict the future. Head back to datasets, go to forecasts, and since this is time series data, as was discussed earlier, we really want to find the appropriate time series chart. So let's do a line chart. Is kind of one of the best ways to visualize this. So you can see some examples here if you're trying to figure out which type of chart. There's over 20 chart types for just time series you can kind of explore on your own. So we're here. So now we need to give some actual metrics for Superset to visualize. So let's look at the predicted rides versus the actual metrics. And we will do rides forecast. Awesome. So Superset's gone ahead and assigned a color to each one of these, and you can see 2020, a year that will forever live in infamy. You can kind of start to see the predictions doing their magic, right? So in March, even when this is for all of the routes, so we haven't filtered this or grouped yet by the route ID. So this is just looking at the aggregate. You can see here that it's kind of keeping up in the beginning however, it's a little bit optimistic here, right? The model hopes that things will kind of go back to normal, and this is very true. This is very common in a lot of time series forecasting models. And then just with kind of another week, the model, another week or two, the model is then correcting itself, and you're finding that the gap between the actual, which is this bottom tealish blue, and this darker blue is the predicted rides. That gap is now is quickly converged. It's almost zero, and then the predictions moving forward are looking really nice and tight. So it's done a really good job learning from data, which is what we expect machine learning models to do. So it's done a really great job of doing that. So next, let's actually save this in our dashboard. And we should be able to add a better, well, let's add a legend. We can also add a data zoom. So this will be fun to actually grab the data when people are playing within the dashboard. Let's give it a name. Actual versus predicted riders. We'll save it in the same dashboard. CTA routes and predictions. Save. Let's go take a look at our dashboard now. Ended up on the bottom by default. Let's move it up over here. Give this a little more space. And the real question is, how much space do we want to give to this map? We actually like it how it is. You know, I'd rather look at time series charts. That's my jam. Hit save. And here we go. This is great. We can now look and compare and kind of cross-reference individual routes on the left, and we can also see the predicted riders and the actual for all of them. But these are, the chart on the right is aggregate. And so let's take the next step and actually facet this a little bit further so people using this dashboard can actually look individually by the routes that interest them the most. So dashboard filters and superset are a really powerful way to make your dashboards more dynamic and basically help you build internal custom data products for your organization, for your team, so they can come in and kind of answer their own question. And so let's build two filters here using this feature. One for the route IDs, so people can pick the routes they're the most interested in, and one for the volatility, so they can kind of filter down to the most or the least volatile routes. So for route IDs, those are going to be discrete values like 1, 2, 3. So we'll keep it at value. We'll call it route. Let's change this to the forecast table. And we'll pick the route here. We want this to apply to both the charts. So they'll both update when people pick the route that they're the most interested in. So this is by default going to let you pick multiple values. So let's do routes 1. Let's just do the first 3. And you can see this in action. So pretty quickly you saw that update. This shows the routes for 1, 100, and 1001 on the map. And on the right, you can see the time series chart. So this is the actual versus predicted for just these 3 routes, which is pretty cool. We can kind of do this similar analysis that we did earlier if you want to look at kind of this volatile initial lockdown period for a coronavirus. We could see March, again, the divergence right here, and then kind of the closing of the gap as things smoothen out a little bit more into April. So pretty cool. Let's clear all of these for now, all these filters for now. Then we'll make one more. We'll do the volatility filter. So we'll do add. That one is going to be, those are going to be float values, so 0 to 100%. So we'll do numerical range, call this volatility. And we will save it. So now we have 2 filters. We have routes, discrete values, and volatility. It's really cool. So now we can just scroll down and zoom in on, let's say we want to do, you know, like 55 and higher. We hit apply, and then we can see the routes that are relevant here get updated. Awesome. So just with a little bit of clicking around, we can see that some of these look really volatile. So that's basically it. You know, we can set this back. Let's clear it up. We can quickly get back to where we were before. So I hope this shows you some of the power of combining MindsDB, Snowflake, and Superset in kind of one workflow. You can quickly build the charts that you need. You can take the insights that MindsDB has generated and the data that Snowflake is storing and quickly build these pretty dashboards and ship them to your internal customers. So thanks again.
Thanks, Srini. This was, I believe, a really good walkthrough from your data in Snowflake, how you can create models with MindsDB, and then do all the magic in Preset, which I believe is a super powerful tool for BI. So please follow through the links in this webinar, and you can follow in through the materials. We're going to put a blog post together that will allow you to walk through this step by step, and you can replicate the same tutorial, and hopefully that will help you use it for your own use cases. We have a handful of questions, and we're going to go through those. So we're going to start with one that Christopher Yerena, he has posted, like, if you want to get the metrics of the model, which is the command query. So MindsDB has a few tables that are metadata tables that you can query the same way that you query any table. And this one is a predictor table. So you go and select MindsDB.predictors, and that will give you information for all the predictors that you have in the database. That's one. And of course, you can add, for the next versions of MindsDB, we have the describe command that we will support for models. So you can describe a model, and it will give you more information for the actual prediction or the actual predictor model and how the model was generated. Similar to that, you can go to the graphical user interface of MindsDB, and you can explore the models, and it'll give you information such as the confusion matrix, the different accuracy criteria that we have. Okay, we have one from Vergali, where the model is running inside Snowflake, how Preset, MindsDB, Snowflake connect to each other. That's a great question. So MindsDB is a layer on top of Snowflake, and it speaks to Snowflake through one of the Snowflake clients that Snowflake provides, or is a case that Snowflake provides. And then you can connect to MindsDB through any MySQL client. Now, Preset can connect to either Snowflake or MindsDB directly. It supports both protocols, and then you can just send queries directly to Snowflake or MindsDB. If you're going to do predictive queries, then you can do them directly into MindsDB. Now, MindsDB supports the capability for you to export the aggregate predictions, like of a join, back into Snowflake if you want to query this directly into Snowflake. Nadia Hamaloui, I'm sorry if I'm mispronouncing your name. Nadia, can we tune the hyperparameters? So MindsDB allows you to specify as much as you want of the model creation part in a similar syntax to the one that you had that I presented on the demo, in which you can specify how you want the encoders to be and the hyperparameters of the encoders, as well as what model you want to pick and those parameters as well. By default, MindsDB tries to figure this out on its own, but you can specify this by yourself. Also, if you describe the model, then it'll tell you what parameters it used and what different building blocks it used to build the model. Okay, so how do you train? This is from Mohammed Tawfiq. How do you train your model, and how do you reduce the error margin in your output data sets? Okay, so MindsDB does a few tricks in the AutoML side. So I'm going to cover this question from the AutoML perspective, because if you know what you want to specify, then you can do it by specifying the parameters yourself. MindsDB breaks down the problem into smaller pieces. The first part that it does is trying to understand the type of columns that you have for your problem. And for that, it tries to identify what is the best encoder or the best way to get an embedding. So say, for instance, if you have time series data, it first tries to understand the different columns and what is the best way to get an embedding for each of the columns. And this does it by trying to implement the state-of-the-art model for this. Like if you have text, it will try to use an embedding using probably some of the GPT models that exist out there. If you have time series data, it can use RNNs or other type of algorithms depending on the dimensionality of your data. And then how you want to combine all of this data into the predictor, it tries a few models. It tries decision trees. It tries how you can combine this with feed-forward neural networks. And the parameters that it uses for this also MindsDB tries a few, and then at the end, it has an aggregate or a composite of what the model will look like. And this essentially is something that MindsDB tries to do by essentially walking through that grid search of parameters. Okay. There's another one from Mohammed, which is whether data are sensible one. How do you deal with critical input set? How do you proceed to collect them? So long your data is in Snowflake, MindsDB allows you to treat the data that you have in Snowflake directly. So the queries that you pass into MindsDB for the data preparation part are directly routed into Snowflake. So long your data and the sensitivity of your data is confined to Snowflake, MindsDB only queries information the way that you specified on how you want to train the model. MindsDB doesn't store any data. At the end, it just queries the data from Snowflake, encodes this data, fits this into the model so the model can be fit. And then at the end, what MindsDB stores is the state of the model. So all your data continues to stay in Snowflake. There's another one from Vindra Kahnai. Which machine learning model algorithm is being used in this example and why? Yeah, that is a great question. So for this particular example, given that it's a multivariate time series model, the first thing that it does is that it creates some embeddings for the actual number of routes. And that embedding is very simple. All that it does is tries to kind of like put it in a log scale because it's all positive. And then it has another one for the date type. And then the timestamp, it also encodes it based on like the month, day, hour, and then it tries to add information as to where that date is weekday or what a day within the week. Now, the next thing that it does is that it tries to get information for the window of time that you have here, which is, I believe, 10. And for that, we use RNNs. And if I'm not mistaken, is a GRU RNN that it uses for this. Now, again, MindsDB tried a few things before this, and then I believe for the end model of this, it picked up actually that type of RNN. There's one from Liu Shang. Does order or group byte matter? Is it impacted by the clustering in Snowflake? So order by is what is telling MindsDB that this is a time series model. It's telling you that there is a column that actually defines a sequence of events or transactions. I apologize. And then the group by is telling you how to actually dissect different types of group bys. Essentially, it's telling it that you have not just one time series model, but you have many ones. In this case, every route has its own set of time steps associated with it. And then MindsDB can treat each of those as an individual time series problem. Okay. There is a question about prices. Right now, you can track MindsDB. MindsDB is an open source project, the same thing as Preset is based on Superset. So Snowflake, you already are probably quite aware of Snowflake pricing, very reasonable, it's very straightforward. MindsDB comes with a cloud offering, which is in case you don't want to manage MindsDB by yourself, you can go through MindsDB Cloud. MindsDB is priced per token, and essentially a token is a cell within a table. And right now, if you register into MindsDB, you have unlimited credits for like the next 3 months. And then after that is 4 cents per token. But that is the pricing model that we have. Do you support NoSQL data management systems? From Lemmy. Yes, Lemmy, we support MongoDB as one of the NoSQL databases that we have. We also have Redis as data sources that you can integrate. And you can mix this data with information that you have in Snowflake as well, all within MindsDB. Nadia is asking, how is it better than working in Python? That is a great question. I think that when you're in Python, thinking of just a model building, you're not thinking too much of the model deployment and moving this into production. At the end, what MindsDB tries to simplify is a few things. That you can build your model in a very declarative way, because building machine learning models today is more like Lego building. You just mix the pieces that are most suited for the problem, but not necessarily you have to reinvent the wheel every time you will need to create a model. So MindsDB tries to save time there so you don't have to write the model from scratch. And the second thing that you want to do is you want to understand how to move that model that you already had in Python into production. So MindsDB creates this abstraction so that it looks and behaves the same or in a similar way than how you create a table in a database, and you consume this in a similar manner. So you don't have to treat your model as an application layer component, but you treat it more as a data layer component. And that way you can streamline the process of machine learning rather than doing a Python script that then you have to wrap around a web service, and then this web service has to be consumed again from some other ETL mechanism, so you can fit data into it and then get those predictions back into the data warehouse. There's one from Stravos Grez. How might MindsDB behave with missing values? Is there any inputting method, remove or replace it? The cool thing is that we deal with Snowflake. So Snowflake is a fantastic data preparation tool in the sense that if you want to remove null values, all you have to do is to set a where condition where you don't want a given column to be null. And all this cleaning you can do in Snowflake. And there's no real reason for us to reinvent all of those capabilities because Snowflake does it very, very well. And we believe that we should leverage on that capability. Now, MindsDB can handle null values if at the end of your query you have null values. But any data preparation step or any data cleaning step you can do in Snowflake, and Snowflake is probably the best tool for you to do it. Okay, so price for Snowflake, price for MindsDB, or on price for presets. So we're all three different companies. We collaborate with each other, and at the end, Snowflake has its way of charging, as a computing service. MindsDB tries to play a similar model, which is by sell, and then preset. You guys are just releasing. I'll let Srini answer that question.
Hey, yeah, actually, I answered in the chat as well, but just to clarify here, so for Preset Cloud, there's a free forever tier, so up to 5 people go nuts. Pretty much everything just works except for things like the API, and then afterwards it's $20 a user a month, and then we also have an enterprise tier if you want like API access and more, just some of the more advanced features. But yeah, we have a free forever tier. So for people who just want to try out, Superset in a hosted environment, that's probably your best bet.
Thanks.
And Miles.
Yeah, and then for Snowflake, it's pretty straightforward. The pricing is per credit, and basically you only pay for what you consume. And so depending on the size of the warehouse that you've chosen for your SQL work, it ranges from 1 credit an hour up to about 32 credits an hour. Each credit is priced based off of the version that you choose. So we have your kind of standard enterprise, business critical, and virtual private Snowflake. Those range between $2 to $6 per credit per hour.
Thank you, Miles. We have another question from Abu. Can you deploy this in financial institution like a bank? If yes, how? I am working with one of the banks in Gambia and the IT support staff, and I would like to raise this technology to my boss. Oh, this is fantastic news. I think that all of the tools that we presented here, Snowflake, MindsDB, Preset, are tools that you can use within the financial sector. Of course, Snowflake has been used many times there too, and Superset and likewise MindsDB. MindsDB is open source, so if you want to deploy it on premise, you can go into mindsdb.com. There is a documentation section on how to do it. And of course, if you want to go into the managed version of MindsDB, then that's something that we can discuss. Please feel free to reach out directly. And likewise, we're going to put the contact information for Miles, Srini, and myself, so you can ask us questions. And then you can also join our Slack, and we can treat this. So Costa from our team will get directly to you, and then we can proceed in that conversation. There's one from Enoch. The question is the predictor available via an API to be queried externally, like directly into Snowflake, once the training has been done into that predicting in MindsDB? So the predictor could be queried directly into MindsDB, and the API is, you can connect to it via the MySQL Wire protocol using any MySQL client or any MySQL SDK. You can also export the predictions back into Snowflake if you want to, not do this in real time, but you actually do it in batch, which in Snowflake is a reasonable approach. And then you use it connecting to Snowflake via the same standard API that they provide for your SDK. There's another one from Nadia. Do we use MindsDB only for time series? MindsDB specializes on problems that are common to the database. And databases being transactional, many of the problems that you have there are time series problems. But of course, MindsDB can help you with problems that are not time series problems. We do provide NLP capabilities if you want to do like some sort of text classification, or even if you have columns that are text and not just time series, MindsDB can take that information into account. And then if your target variable, it only involves information for one single row, either being a prediction or for classification or regression, MindsDB can tackle those problems as well. The reason why we presented time series is because those problems tend to be harder to solve, even if you are well suited in machine learning, because of the capabilities that you need to kind of build, which are you need to deal with not just time series, but multivariate time series, and then high degrees of cardinality. But MindsDB can deal with less complex data types and problem. And yeah, classification regression is something that we do. Well, this is a cool thing. There's another one from Ragali. How many different time series problems exist in general? Is machine learning the solution for most? So time series is something that has been around for ever since we started storing data in a like linear way. The problems that you have are presented in most databases. At the end, if you have transactions and transactions have a timestamp associated with it, then one intuitive problem that you have is you want to forecast how those transactions will look like in the future, like in the next n number of steps. There's another use case for time series, which is anomaly detection, which Srini was walking you through. For instance, when the pandemic started, you could see how the number of flights dropped. And you can actually flag that as anomaly when the model is forecasting something that is different from the data at that time. And if the model tends to be very accurate, then you can see, well, the data is starting to behave not in a normal way, which, as you saw it on the demo we show you, when the pandemic started, the model forecasting started to kind of drop, and you kind of flag this as anomaly. So time series is the bread and butter of data. Like in financial institutions, if you have transactions from users, and if a transaction is different from or an outlier from the forecast, then you can flag this anomaly, or you can forecast portfolios of costs or spending, anything that has some historical data, which again tends to be what most people store in databases and what most information that you can put into Snowflake, then you can treat as a time series problem. And MindsDB is probably the most sophisticated tool for you to build models for that. Sorry, I had forgotten to start the camera. Do we use my, I think that we've covered most of the questions. Which is great because we also ran out of time. But thank you so much for joining us and for all your questions. Thanks, Srini. Thank you, Miles. This was a pleasure.
Yeah, thanks for hosting us.
Yeah, thank you as well.
Bye.
Bye. Take it easy.